Okay, so we're going to prove the hypotenuse leg theorem, which states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So in this diagram, we have if the measure of angle A is equal to 90, which is equal to the measure of angle E, indicating that these two are both right triangles. AB is congruent to EF, and BC is congruent to FG, then we know triangle ABC is congruent to triangle EFG. So let's go ahead and start the proof. So we know these are both right triangles, so we can use the Pythagorean theorem on both of these. So by the Pythagorean theorem, we know that AB squared plus AC squared is equal to BC squared. And we have that EF squared plus EG squared is equal to FG squared. Okay, so now what we have is we know that BC is congruent to FG. So let's go ahead and write that. BC is congruent to FG. So this implies that BC is equal to FG, right? And of course, this implies that BC squared is equal to FG squared. So we know these two are actually equal to each other. So that means these two sums are equal to each other. So let's go ahead and write that down now. So this implies that AB squared plus AC squared is equal to EF squared plus EG squared. And now we know that AB is congruent to EF, so instead of writing AB and EF here, I can write AB squared plus AC squared is equal to AB squared plus EG squared, because I know that EF is congruent to AB. So since I have AB on both sides, I can subtract it from both sides to get AC squared is equal to EG squared. And then, of course, I can take the square root of both sides to get AC is equal to EG, right? Since both of them are positive, if I take the square root, I don't have to worry about the negative solution because they're both positive. And then, of course, this implies that AC is congruent to EG, right? Now, I have AB, so this is what I have. I have AB is congruent to EF, right? I have BC is congruent to FG, and I have AC is congruent to EG. So that means by the side-side-side congruency postulate that these two triangles are congruent. So let's go ahead and write that up here. So from the assumptions, I knew that AB was congruent to EF. I knew that BC was congruent to, right? BC was congruent to FG, right? And then what I just proved, I have AC is congruent to EG. So AC is congruent to EG, right? So by the side-side-side congruency postulate, I know that triangle ABC, right? Triangle ABC would be congruent to triangle EFG, right? And that is what I set out to do. I wanted to prove that both those triangles were congruent. And that is the proof.